Merge sort. Our next two algorithms are very different from selection sort and insertion sort. Merge sort and quick sort are both recursive. Instead of looping repeatedly over lists, they use a divide and conquer approach, breaking lists into smaller and smaller pieces and then putting them back together again in order. The code for these two algorithms is more complicated, and you are not expected to be able to write them for the AP test. So we will learn in general how they work and what their strengths and weaknesses are, but we will not dissect the code line by line. Recursive sorting also has implications for the idea of passes and steps. Since recursive algorithms don't iterate over the entire array, it doesn't make passes in the same way. But recursive algorithms take steps, comparing and sometimes swapping two elements at a time, and the total number of steps is still what matters for efficiency. Merge sort is named because it merges two sorted lists together. What is merging? Imagine we have two sorted arrays right here, color-coded only for clarity. Imagine stretching those two arrays out and then zipping them together. That's the merge in merge sort. It takes two sorted arrays and combines them into one sorted array with relatively few of those expensive comparison operations. So imagine a method called merge that takes two sorted arrays and merges them into a larger array. We don't need to worry about writing this code or the implementation, but let's assume it correctly zippers array A and array B into array. The code is provided on the next slide, as well as in the zippered folder discussed at the beginning of this unit. So how do we use it? Let's write another method. Here is the merge method. Let's write a merge sort method with some comments where we don't know exactly what to do. We know we want to take an array as an input, break it in half, sort the two halves, and then merge them back together. Let's not worry about how we initialize and fill the two halves. You can figure that out. But how do we actually sort things? Easy. So here, we initialize first half and second half, and then fill them with elements from array. Then we're going to sort first half, sort second half, and now merge both halves back into the array using this method call. We use merge sort, the method we just wrote. So we're going to call merge sort on itself here with first half and second half. Do you see something missing here? This is recursion, and we know that recursion requires a base case, or we will get a Stack Overflow. What's the base case here? Since we are breaking our arrays in half each time, eventually we will get to arrays with exactly one element. And an array with one element is already sorted. So when we get to arrays of size 1, we can just return. And that's it. Merge sort is done. Notice the last line, return. What is being returned and why are we not specifying? This line exits the method if the length of the array is 1.